Hi guys, welcome to this masterclass on SAT, and today we'll be dealing with a topic which baffles most of the students during an SAT exam. The topic is very simple, it's linear system of equations. Though it appears simple, but still there are tricky questions, two of them which we'll be discussing, which can confuse the student in an exam. Okay, so let's begin. The first question being this. If a system has infinitely many solutions, find the value of A over B. So before beginning, what infinitely many solutions means? So it's very easy to deal with this question algebraically, but let's just try to visualize it graphically so that it becomes easier for us. Okay, so if I just plot this thing graphically, what does it mean? These two are linear equations. So linear equations are generally plotted as graphs, right? So the graphs of these equations will be some straight lines like this. So once we know that the graph is a straight line, infinitely many solutions means that the lines are simply overlapping. Then only infinitely many solutions are possible. So now once we are clear that these two lines are overlapping over each other, what does it mean? It simply means that both these equations are exactly the same equations. So why do they appear different? So they appear different because second equation has to be a scalar multiple of the first equation. What does it mean? It simply means that if you multiply a first entire equation by any number, you will get the second equation. Then only these two equations will be the same equation, eventually be the same equation, and will have the same or infinitely many solutions. Correct? So if I look at the constant part, 12 is just becoming 3 times of itself. So this 12, if I multiply it by 3, I'm getting the constant of the second equation. So same logic must apply to the coefficient of x and to the coefficient of y, right? So 3 when multiplied by 3 should give you a, and 5 when multiplied by 3 should give you b. So 3 multiplied 3 is what? 9. And 5 multiplied 3 is what? 15. So now we have the values of a and b. Once we have the values of a and b, we can simply calculate the value of a divided by b. So 9 by 15 is simple. 9 by 15, we can simplify that and we can get 3 by 5. So the answer to the question is 3 by 5. Got it? So this was the solution. This is a simple solution of this problem. Okay? Let's go to our next problem. Next problem is based on a real world constraint problem. The problem is right in front of us. It's a local theater type setting which sells both adult tickets for $14 each and student tickets for $8 each. For some specific show, the theater sold at least 120 tickets and brought in a total revenue of no more than $1,300, means a maximum revenue of $1,300. If X represents the number of adult tickets sold, what is the maximum possible value of X? This is what they're asking. So what needs to be done in this question is you have to algebraically write this equation, and that's it. Once you are able to do that, the solution is right in front of you, right? So how we are going to do it? Simple. First constraint. Locals adult ticket cost $14. How many tickets are there? X tickets are there. Let we have Y number of student tickets. So X number of adult tickets, Y number of student tickets. For some specific show, the theater sold at least 120 tickets. What does it mean? At least 120 tickets. X plus Y at least means has to be greater than or equals to 120. Right? So this is the first equation. Next, coming to the another statement, and brought in a total revenue of no more than $1,300, means no more than means less than equals to $1,300. And what is that $1,300? It is the revenue. And what generates this revenue? By selling $14 per ticket of an adult ticket and an $8 per ticket for a student ticket. So if adult tickets are X number, 14 is the price of one, so 14X will be the price for total adult tickets plus 8Y will be the price for total number of total student tickets. So this 14X plus 8Y is less than or equal to 1300. Now what they're asking, if X represents the number of adult tickets, what is the maximum possible value of X is what they're asking, right? They're asking what is the maximum possible value of X. So how can we get the maximum possible value of X? See, in this equation, in the second equation, X can go maximum. There are two variables. X can go simply maximum only if the other variable goes minimum. Correct? Both are variables. If one variable goes up, let's say the minimum constraint, 14x plus 8y is equals to 1300. If x goes up, y goes down. So there is a limit to a minimum value of y, how, based on the first equation, right? So if I look at first equation, x plus y is greater than or equals to 120, means it's a minimum value of y. So if I look at y has to be at least greater than or equals to 120 minus x. So I will this is the minimum value of y. So minimum value of y will be 120 minus x. So if I substitute 120 minus x in this equation, it will get me the maximum value of x. So this is all I need to do. 8, 120 minus x. For this constraint, I need to use this equality 14x plus 8 into 120 minus 6, which will give me 14 minus 8 is 6x plus 960 less than equals to 1300. And this 1300 minus 960 is how much? Oh, 13 minus 9, 12 minus 9 is 3. And if it divides by 6, what does it get us? So 6 5 6 5 30, 6 36 5 30 46 6 36, around 56. So the number of the maximum possible value of x here would be 56. Got it? So this is how you'll approach the problem in the actual SAT exam. Right? We'll be coming with more topics and more number of questions in our next video. Thank you.